Hey everybody, my name's Nick Alumbaugh, and today I'll be walking you through the evolution of a code journey through software development. We're going to take a look at how software has grown over time, from its early beginnings to where we are today, and how the past continues to shape the tools and methods that we use now. So, we'll explore some exciting trends that are changing the future of development. So, to really understand where software is heading, it helps to know where it started. Back in the 1800s, Charles Babbage came up with the idea of the analytical engine, and Ada Lovelace, who worked with him, actually wrote the first algorithm for it. This makes her the first computer programmer of all time. Jump ahead to the 1940s, and we have machines like the ENIAC, which had to be physically rewired for different tasks. Alan Turing, another major figure, introduced the idea of stored programs, which is something that we use today still. So then, in 1948, Tom Kilborn wrote what is considered to be the first actual piece of software. And a fun fact, the word software didn't really take off until around 1952. Early on, women weren't really uh, considered to be ones who were leading software, but actually they really were. Think of the ENIAC programmer and Grace Hopper, who built the first compiler and helped shape COBOL. Software development evolved through a few key phrases. The Foundation era in the 50s and the 60s gave us the first high level language like Fortran and COBOL, using punch cards and batch processing. The structured era of the 70s and the 80s brought languages like Pascal and C, along with the rise of personal computers and the birth of software engineering, thanks to the so called software crisis. Then came the object oriented and web era of the 90s and 2000s with Java and C, the explosion of the internet, and the rise of open source agile development also took root during this time. All these parts help to change how we write code today. In procedural programming, code runs in a straight line. Functions act on data, and everything happens in a set order. Object oriented programming changed that. Now we are more wrapped into data and behavior together in objects. With encapsulation, inheritance, and polymorphism, we have gained more structure and flexibility than ever before. Still, however, no matter the style, the basics, variable loops, and conditionals are always there. Today's language often blend multiple paradigms, combining procedural, object oriented, and even functional programming. Globalization has totally reshaped software development. Teams now get to work across different time zones and cultures simultaneously, which means that we need to design software that works worldwide and build tools that support a global network and a global teamwork. Having diverse teams is a huge advantage. Different perspectives improve problem solving and innovation. Teams like that also design better products because they are better to understand a wider range of end users, which helps also to reduce bias. History shows us that diversity has always been a part of computing and actually in all of human evolution. If it wasn't already recognized, it should be. We talked about Ada Lovelace and Grace Hopper and how Katherine Johnson's math was a key to the early NASA missions. And now, thanks to open source, people all over the world can contribute to major projects regarding of multiple scenarios with any type of background. So what's happening today in software? A few major trends are shaping the landscape. AI and machine learning are becoming integrated into everyday tools. GitHub Copilot, for example, helps developers write code faster. Cloud native development is changing how apps are built using microservices, containers, and serverless platforms to scale and deploy quickly. DevOps and agile practices are streamlining the whole development cycle with continuous integration and delivery, making things faster and more reliable. Low code and no code platforms are making it even more easy for non programmers to create apps, which really opens up development to a wider range of people. To wrap things up, software development has come a very long way. We've gone from rewiring hardware to building in the cloud with AI support. But some things haven't really changed. Creativity, collaboration, and adaptability are still at the core of what makes great software. Looking ahead, AI will play a bigger role in assigning developers, but it won't replace them. Development will keep moving forward towards serverless and edge computing for better performance. Security will be built into the process instead of being bolted on later. And more people will be able to build software thanks to low code tools like AI. I'd like to acknowledge the resources that informed this presentation, including historical works by Paul Cerezi and Nathan Esminger, programming paradigm resources like the classic design patterns by the Gang of Four, and Robert Martin's Clean Code, diversity research from McKinsey and Company, and current trends from information regarding leaders like NetGuru and Atlassian. Thank you.